Hello, student. Today we shall discuss the spiral model of the software development life cycle. This software model is a very traditional advanced model which inherits the good properties of nearly most of the software development cycle, and it can work accordingly. This is the project model has a unique uh, points that it considered the project risk associated with every project that has been neglected by the other software designing lifecycle model. Like in other model, when we mostly what we do, either we design prototype or we design them using the certain sequence of steps. In some, there are some iterative operations are take place, and these iterative operations take place on the sometime, like an iterative enhancement model. What we do, we first satisfy a design model, so depending considering the subset of requirement. After that we add on some few more requirement and again start the procedure of design, coding and implementation. In all these steps, and similarly in prototype model, first we built a prototype. It is validated by the customer. If it is validated by the customer, then okay, otherwise it is redesigned. So in all these life cycle model that we have discussed till date, what we do normally, we design or modify our prototype or release in each iteration. But while modifying, we have not considered that there is always a process. This is not only the requirement that we should consider. We should also consider that there are certain risks that are associated with the project in each round steps. Okay, so most of the software fails because of these project risk, and if we do not consider this and or analyze the risk associated in each model, then we cannot design an efficient life cycle model. So Barry Boehm was the person who introduced the project risk factor into the life cycle model, and he proposed the spiral model for software development life cycle. In 1986, Boehm shows the following figure like this. Here, this diagram, you may can see that here again, there are some steps which are common in every round. That in each round, there is a prototype. At first round, there is a prototype 1, then prototype 2, prototype 3, and in final round, we get an operational prototype. So in every round, we design a prototype like in prototype model. So this feature is similar to the prototype model, and this model may be compared with the prototype model. But once we get the operational prototype, after that, we are following the steps like detailed design, and we perform detailed designing, and after that the steps are followed are coding, unit testing, integration testing, acceptance testing and implementation testing. This part is very much similar to the waterfall model. So it consists of also the features of the waterfall model once the operational prototypes become functional available. And another thing is, like in other model, here then each round there is a field risk analysis associated in each cycle. The risk analysis, there is a risk analysis field in each cycle, and in each cycle there are different sectors. तो हम यहाँ देख सकते हैं कि हमारे क्वाड्रेंट को अगर हम लोग देखें तो हर क्वाड्रेंट में जो है ये सेक्टर्स हैं उसके में डिवाइडेड है, और इसके अंदर आप लोग कुछ और देखेंगे। अगर हम लोग इसको क्वाड्रेंट डिवाइड कर दें तो इसमें दिखाई दे रहा है कि जो फर्स्ट क्वाड्रेंट है, व्हाट इट डज इन दिस फर्स्ट क्वाड्रेंट, डिटरमाइन ऑब्जेक्टिव, अल्टरनेटिव एंड कंस्ट्रेंट्स. First, we defined that while designing the another prototype, we set out the objectives, the alternatives, and the constraint. After that, when after this, the progress towards the after considering the risk analysis, in which what we do in risk analysis, we evaluate alternatives and identify and resolve the risk associated with them. Suppose if there are two options and we are considering or we are designing using the first option and we are not using the second option, then we shall find out that what are the risks if we choose what are the risks if we opt for path one. For example, if you are at a crossroad and there are four paths which led you to the in different direction, and at that point you choose one path, then here you are ignoring three paths which are in different directions. Suppose you are moving toward the east, then you are not taking the options associated with the west, south, and north. So you should check out what were the alternative at that step and what are the risks that could occur if you only leave that options. So you should check out every possibilities that could arise if you go for one options only, select one option, and if you have ignored some of the option which could have been the alternatives. So if you do not find out the alternate options, then there may be situations when the project become functional, the some unexpected outcome may occur because of the some altered choices made by the user. So here in the second, once the objective are determined, alternative and constraint are checked out, then after developing, we find out if we are opting certain alternative, what are the risks that could be associated with that if we go for that option and leaving the other. And so in this, each cycle is having a risk analysis phase in which we check out. The radial dimension of the model represents the cumulative cost. The radial dimension means its curvature-like dimension. Cumulative means overall cost. Like in the prototype model, you know that once you design a prototype and if it is validated by the customer, then considering the new alternate requirements, you need to design the or code the project once again, because the code used for developing the prototype one cannot be used to design prototype 2. Like I have told you that suppose if there are 100 requirements and you are designing a project, that first you shall design a prototype you considering only 20 requirements out of 100. Then you shall code according to 20 requirements only, and next time when you consider 20 more requirements, means total 40 requirements, you cannot reuse the code that were designed to prototype that was sufficient or that was satisfying the 20 requirements only. Because in programming, you know that it is very difficult to modify a code which are defined for suppose 10 variables and modifying this program for 20 variables. The time required to modify or update and run the modified code is more than the actual time required to rebuild the code. That's why when we design a prototype, what we and it is validated, then then for the next subset of queries, we need to redesign the code, and we do not invest time in modifying the code and finding the error. So the cost associated is total is equal to cumulative cost, and so each path around the spiral is indicative of the increased cost. Suppose model cost, the more number of iteration, the more the cycle number of cycle, the more the cumulative cost it will have. The angular dimension represents the progress made in complete each cycle. The angular dimensions represents the progress made in each cycle. If the number of cycle increases, it represents that the cost is increases. Suppose if you need to develop or design 10 number of prototype, then its cost would be greater than the mod project that is developed using the 5 prototype. and five cycles. And similarly, the progress of the particular cycle is represented by its angular dimension. And now the each loop of the spiral from x-axis clockwise through 360-degree represent one phase. And each loop on the spiral from the x-axis clockwise through 360-degree represents one phase. And one phase is roughly split into 4 sectors of the major activity. So there are multiple cycles in it, and there are one cycle is called a phase, and each phase is roughly divided into the 4 sectors of 4 sectors. So here in the above diagram, there are 4 cycles, and each cycle is divided into the 4 phases. So the phases here are the plan next phase. For the phases are develop, verify. The first phase is determine objective, alternative, and constraint. And constraint next is evaluate, alternative, identify, resolve risk is the second phase. First, we shall determine what are the objective and alternative and constraint of the prototype in first phase. In the second phase, we shall find out the alternative that could be taken, but and if we ignore these alternative, then what are the risks that could be generated if we opt for these alternative. The next phase is designing phase, in development phase, in which we develop the prototype and verify the next level project. And in the next phase, fourth phase, we find out the plan and next phase. So there are total 4 phases. Phase 1 is determine objective and alternative constraint. Second phase, evaluate and identify and resolve the risk. In third phase, develop, verify the next level project. And in fourth phase, plan the next phases. So there are 4 phases in each cycle. So the phases are, one phase is split more than 4 sectors. So first phase is planning, in which I have told you that they determine objective, alternative, and constraint. In risk analysis, we analyze alternative and identify and resolve the risk involved. In third phase is development phase, where product development and testing products. And last one is assessment, which is the customer evaluation phase. Okay, so during the first phase, planning is performed, risks are analyzed, prototype are built, and customer evaluate the prototype. In the first round, what we do in the first round, a planning is done. After that, risks are analyzed, a prototype is built up, and it is evaluated by the customer. That is the first phase, means first cycle. In the second cycle, a more refined prototype is built, requirements are documented and validated, and customers are involved in assessing a new prototype. With help of the customer, we refine our product, and we try to refine our product and perform the and do the required documentation work. In the third phase begins, risks are known, and somewhat more traditional development approaches taken, like traditional approaches like waterfall model steps. When you get the operational prototype or the final prototype, in which you have defined your requirements and the customer has validated, then you prepare the final design, and after that you follow up the procedure of traditional software development life cycles for the development of the final product. The focus is the identification of problem and the classification of these into different level of risk. Here, different types of risk are divided into different phases or layers. The aim of being eliminating the high risk problem before they are threatening the software operational cost. So in this way, because of the risk analysis, we try to eliminate as much as number of error as early as possible. So the chances of success of the software increases, and any threat of the or error situations are ignored to the least. In this, the possible risk associated with the projects are identified, and the factors which could create high risk to the development of the softwares are eliminated in the early phases of the development. An important feature of the spiral model is that each phase is completed with a review by a people concerned with the project. Like in the prototype model, in the spiral model, for a phase is completed by the validation or review of the customers. If the at the end of a phase, a prototype is given to the customer to validate the requirement, and once the customer gives its feedback, as per his feedback, the new requirement are set up and prototype is refined. For the review that customer gives to the developer consists of a review of all the product development up to that point and include the plan for the next level. It gives in the review, customer gives the review for the current prototype that he is working on, and he proposed new idea and suggestions or which defines the plan for the next round or cycle. These plans may include a partition of the project into the smaller portion for development or component that are implemented by individual group or person. Suppose there is a large size product, then it is divided into modules or small portions, and different teams are or groups are implement those portions or implement those portions or develop those portions. If the plan for development fail, then the spiral is terminated. Suppose if somehow the planning procedures fail, on that situation, that spiral is terminated. Otherwise, it terminates with the initiation of the new software. If somehow the procedure of development fails, our planning phase fails, then the process is stopped. If it does not fail, then we start for a new iteration or new modified software. This spiral model has an advantage that it has a wide range of options to accommodate the good feature of the other software as software development life cycles. Like in the last one, we get the final operational prototype, which which is validated by the customer. We can go for waterfall model. Like here in the last phase, last sector, you may see that after operational prototype and detailed designing, the coding step are similar to the waterfall model. The coding, unit testing, integration testing, acceptance testing, and implementation. And like the prototype model, the customer can get or validate prototype at end of each phase. So it consists of the feature of both the popular life cycle model. Okay. The spiral model, it also incorporates software quality objective into the software development. It minimizes the risk by considering the risk, performing the risk analysis at each phase. So it eliminates chances of error in very early phase of development. So we try to remove the most of the error as early as possible in this. So these are the advantage of the spiral model. Now, spiral model has some difficulties that need to be resolved before it can be universally applied life cycle model. अब इसमें इतने एडवांटेजेस हैं, तो क्या इसको यूनिवर्सल लाइफ साइकिल मॉडल बनाया जा सकता है? तो अभी ऐसा नहीं है. द डिफिकल्टी इंक्लूड्स द लैक ऑफ एक्सप्लिसिटली प्रोसीजर गाइडेंस इन डिटरमाइनिंग ऑब्जेक्टिव कंस्ट्रेंट अल्टरनेटिव and relying on risk assessment expertise and providing more flexibility than required for any application, many application. It is well defined risk analysis phase, but even after the risk analysis, analyzing the risk associated with each prototype in each phase, the procedure of determining the objective, constraint, and alternatives are not well defined. So, how to define the next objective or constraint or alternative? First, you need to identify the alternative, then the associated risk. But there is no certain procedure through which we can define what the alternative could be at each phase. And so, risk analysis is done just by the expert, and we depend on the expertise of the personnel who is doing the risk analysis. So there is no well-defined procedure for finding out the risk or risk analysis. So even after this, there is no surety that after doing all these phases in each round, there could not be any risk associated with the software. So these are the shortcomings. Now here in this diagram, and you may check out that in each steps, the first software we're starting from first requirement plan of first a plan is made, then we find out the risk analysis, then prototype one is created, then operational concept, उसके बाद नेक्स्ट फेज के लिए प्लानिंग की जाएगी. अगर आप राउंड वाइज देखें तो फिर रिस्क एनालिसिस, फिर सेकंड प्रोटोटाइप. आफ्टर दैट the new software requirement are set up. These requirements are validated with the customer in the second round, and after development plan, again the risk associated with that plans are considered, and a new prototype is configured. This new prototype is validated by the customer, and the new software are designed, and after the design validation and verification from the customer, finally the integration testing is done. And likewise, we end up till we get a final operational prototype. And once we get the operational prototype, the procedure of waterfall model are followed. So this model is very efficient model, and this was invented by the Boehm in 1986, Barry Boehm. So that's all about the spiral model of software development lifecycle.